Welcome to The Explainer. Today, we're diving deep into the mathematical building blocks that professionals actually use to construct resilient, survival-focused portfolios. We're going to take a comprehensive look at the real mechanics behind expected returns, covariance, and honestly, one of the absolutely most powerful risk management tools out there, Roy's Safety First criterion. So let's just jump right into this by asking the ultimate question. How can we use math as a survival tool to prevent our portfolios from falling below our absolute worst case scenario? Because let's face it, when the market turns hostile, relying on a gut feeling just isn't going to cut it. We need a mathematical guarantee that we've structured our assets to stay above the waterline. To get there, here's our roadmap for today. First, return and the weighted average. Second, covariance and correlation. Third, calculating portfolio variance. Fourth, understanding shortfall risk. And finally, number 5, Roy's Safety First criterion. All right, let's kick things off with Section 1, return and the weighted average. Now, calculating expected portfolio return is elegantly simple. You don't need some complex algorithm, you really just take the weighted average. Take a look at this hypothetical 3-asset portfolio. We've got 50% in the S&P 500 expecting 13%, 25% in corporate bonds expecting 6%, and 25% in the MSCI EFA expecting 15%. You just multiply each weight by its expected return and add them all up. So half of 13 plus a quarter of 6 plus a quarter of 15. The math spits out an incredibly clean 11.75% expected portfolio return. Easy, right? Moving right along to Section 2, covariance and correlation. We absolutely have to talk about covariance. The best way to think about covariance is like the behavioral trait of two teammates. If they tend to move in the exact same direction at the same time, meaning when one is performing above average, the other is too, well, the covariance is positive. If they move in opposite directions, it's negative. And if they just completely ignore each other, the covariance is 0. But here's the catch. Covariance has a massive communication problem. The number it gives you is in square units, like percent squared, which makes it literally impossible to intuitively grasp the magnitude. So enter correlation. Correlation takes all that co-movement and standardizes it so we can actually make sense of it at a glance. And this comparison brilliantly illustrates why correlation is the go-to metric for day-to-day analysis. It strips away those weird, confusing squared units of covariance and hands us a pure, clean number bounded perfectly between -1 and +1. A correlation of +1, perfect lockstep movement. -1, perfect opposite movement. It tells us exactly what we need to know about how two assets behave together, no math degree required. Okay, on to Section 3, calculating portfolio variance. Now, to find the total portfolio variance, we can't just look at the individual risks in a vacuum. Notice this matrix for a 3-asset portfolio. Right down that diagonal, you see the individual variances, how asset A varies with itself, B with B, and C with C. But look at all those off-diagonal boxes. Those are the covariances between the different assets. We literally have to add up every single one of these terms to find our true total portfolio risk. So the crucial takeaway here is that as you add more assets, how they co-vary together becomes vastly more important than their standalone risks. A simple 3-asset portfolio has 3 variance terms, but 6 covariance terms. But just look what happens when we scale up to a standard 20-asset portfolio. You still only have 20 individual variance terms, but a staggering 380 covariance terms. In large portfolios, covariance is the absolute dictator of your aggregate risk, and the lower the covariance between your assets, the significantly higher your diversification benefit. Let's bring this back to reality in Section 4, understanding shortfall risk. We call this dynamic shortfall risk, and it is really the human element of portfolio math. It is the absolute danger of a client failing to meet their minimum survival threshold. Think about a retiree who needs to withdraw a specific amount every single year without invading their principal balance. If their portfolio drops below the return required to fund that withdrawal, they fail. Plain and simple. That is shortfall risk. To visualize this, notice the shaded green areas on these distributions. The vertical black line on the left of each chart represents a minimum acceptable return of 2%. That shaded green area? That's our mathematical danger zone. It represents the precise probability that the portfolio's return will drop below our absolute 2% floor. Ultimately, our entire goal here is to make that green area as tiny as mathematically possible. Which perfectly sets up our final topic, Section 5, Roy's Safety First criterion. Way back in 1952, A.D. Roy formalized a brilliant solution to this exact problem. Roy's safety-first criterion explicitly tells us that the best portfolio isn't necessarily the one dangling the highest expected return. Nope. The optimal portfolio is the one that minimizes the probability of falling below your survival threshold. It's the portfolio that keeps you the furthest away from financial disaster. And we measure this using the safety-first ratio, or SFR. The formula is beautifully logical. You take your expected portfolio return, subtract your absolute minimum threshold, and then divide that entire number by your portfolio's standard deviation. Basically, what this formula does is calculate the distance from your expected return straight down to your disaster threshold, measured in units of risk. The bigger the number it spits out, the bigger your safety cushion. Applying this is a completely objective two-step process. Step 1, run that formula for every single portfolio option you're considering. Step 2, just pick the biggest number. That highest number mathematically represents the lowest probability of ruin. Let's look at this in action, because this is where it gets fun. We have a hypothetical client who needs a strict minimum 3.75% return to survive without eating into their principal. We're looking at 3 allocations, A, B, and C. Allocation A has a massive 25% expected return, but a wild 27% standard deviation. Allocation B is way more conservative, 11% return, but only 8% risk. And allocation C is kind of hovering in the middle. So which of these 3 should they pick to minimize their chance of failure? Well, the math gives us an SFR ratio of exactly 0.90625 for allocation B. Let's quickly break that down. 11% expected return minus the 3.75% threshold equals 7.25%. Divide that by the 8% standard deviation, and boom, you get 0.90625. Now, if you run that same math on allocation A, despite its massive 25% return, its high risk drags its SFR ratio down to just 0.787. Allocation B's ratio is the clear winner. By choosing the highest safety-first ratio, we mathematically prove allocation B is the superior choice for this specific client. This SF ratio translates to limiting our chance of absolute ruin to just 18.2%. Any other allocation on that board, even the one with the huge 25% expected return, would actually give this client a higher mathematical probability of failing to meet their minimum goal. As we wrap up this explainer, I really want to leave you with this thought. Portfolio math isn't just about blindly chasing the highest possible yield. It is fundamentally about survival. You absolutely have to know your threshold. So ask yourself, what is your own absolute minimum acceptable return? And more importantly, is your current portfolio mathematically built to protect it? Thanks for learning with us today.